Hello, everybody. Thanks for joining us today. We are live to talk about, believe it or not, football. So, we have some really interesting stuff today. We're going to be talking about the NFL NextGen Stats solution, which is powered by machine learning. But before we get into that, let's do some quick introductions. My name is Morgan Willis. I'm a senior developer advocate here with AWS, focusing on generative AI. And I'm joined by Alex.
Hi, folks. I'm Alex Galvin. I'm a senior video person. I get to make all these fun content and streaming. And we've also got Keegan here with us.
Hey, everyone. I'm Keegan Abdu. I'm a senior manager of research and analytics with the NextGen Stats group at the NFL. I help handle, lead stat development during our off season. And then during the season, I lead a team of about 10 analysts who support our broadcast partners with pregame and in-game research to help tell better stories about what's happening on the field.
Awesome. That's really cool. So how did you tell us a little bit about your journey of how you ended up doing this at the NFL? I feel like that sounds like a really cool job that people would be interested in hearing how you got there.
Yeah, absolutely. So I pretty much always knew I wanted to work in football from a very early age when I started playing in fourth grade, but I was never particularly good at football. So figured my career path would have to go a different way. So when I was applying to colleges, I made sure to meet with the coaching staff of each of the schools I got into to make sure that there was the opportunity to volunteer there. I ended up going to Vanderbilt University in Nashville, Tennessee, worked for the football staff under James Franklin there the first 2 years. He was the recently fired head coach of Penn State. He's now at Virginia Tech. And pretty much worked my way through, got some experience here and there, had an internship at the NFL as a rising senior. But really, it took 2 years out of college. I was doing charting. So charting game film manually, which is ironically, a lot of the stuff we get in real time now, and a lot of the ways that we've trained our models to kind of classify those on-field football concepts. During my senior year, actually, I also was one of the video loggers in the stadium for the first year where they collected NextGen Stats. So as soon as I figured out about NextGen Stats, I'm like, how can I get involved in that department? A couple of years later, I apply for the position and I enter as a seasonal employee, do that for 4 seasons, finally become full-time in around 2023. And I've, helped see the team grow ever since then. So it's been a long journey, but, one that's been almost a decade or a little bit over a decade in the making.
That's awesome. Yeah, I think that it sounds like you had a good backdoor into football. Instead of being a player, you're able to work on the back end, but that really impacts the way that the game is played, right? So I think that, that type of work is super important to the game and also to the fans. Really quick, I do want to call out that this is live. So for those of you who are watching currently, feel free to ask questions in the chat. We have some chat moderators. If our chat moderators want to say hello, feel free to ask any questions that you have, and we will do our best to answer them here. So we're here to talk about NextGen Stats. Let's go ahead and kick that off. Alex, go ahead.
Yeah, so thanks for joining us, Keegan. We're really here because one, we love using AWS. I think, we get to work at AWS and use it all the time. And personally, I love when we get to use AWS for kind of new or more kind of novel concepts, more interesting things, diving into how it actually builds and, runs things that maybe folks don't necessarily expect. So when we got a chance to go and work with the folks at the NFL, we jumped right on it. So I guess to start things off, Keegan, could you just walk us through a little bit of what is NextGen Stats for those folks who aren't maybe familiar with the platform?
Yeah, so NextGen Stats is the player tracking operation for the NFL. We've been collecting every player's kind of location and the spatiotemporal data from every game over the last decade. And with that, we're able to scale up, a very wide and vast toolbox of statistics and tendencies that we're able to, tell better stories about the game from a broadcast perspective. And then also, almost every team has an analytics department that is diving deep into this data to pick up on opponent tendencies, monitor their own player health and safety. It gets used from the player health and safety department at the NFL to help make the game safer, and help advise on potential rule changes. It's really become this very essential part to the NFL's continuing operation.
Wow. So it's safe to say if folks have seen a game in the last few years, they've seen some sort of impact of NextGen stats.
Yeah. So it's actually a funny story. When I first started working at the NFL in 2018, and I would tell people, I work for the NFL. Oh, that's so cool. What do you do there? I work with NextGen stats. You ever heard about it? Probably about like 10% of people might have heard about it. We would be, we'd have one sponsored execution a week in the Sunday Night Football broadcast. And if you blinked, you could miss it. And now it's really hard to miss. When I tell people I work for NextGen stats now, pretty much 90% of people who are even average or casual football fans are like, oh yeah, I know what that is. We've seen, we've grown to support every single broadcast crew. We actually just hit 1,000 integrations this regular season for the first time, and I've seen it grow pretty exponentially over the past couple of years, where it's become kind of a very ingrained part of every NFL broadcast. It's been we're really proud of the work that we've done and the growth that we've seen.
Yeah, absolutely. It's really scaled up. Now, speaking of stats, there's been stats around sports basically since the beginning of sports. How is NextGen stats different from your traditional, stats people might be familiar with?
Yeah, so there's the official stat collection operation at the NFL, GSIS, and they're the ones that put together the game books where you'll see, passing yards, sacks, tackles, receptions, all the things that you can go back to 1984 and compare players across that data frame. It's a lot more simple. It's telling you the result of what happened, not necessarily how it happened or why it happened. And you can imagine with NGS and the pure just volume of data that we're collecting on a play, you can build a lot of cool stats and a lot of different classifications and tendencies from that data. So we collect over 500 different stats in real time. That can be anything from how far a throw was thrown past the line of scrimmage, to whether a defense got pressure, to what coverage the defense was playing, to what routes the receivers were running, who was blocking who was covering who. We've really leveled it up to kind of dive a lot deeper into the individual matchups and responsibilities that make up a football play.
Awesome. So one question about this is, how exactly you mentioned before earlier when you were talking that this has impacted the game. It's changed the game. What are some ways that NextGen stats has impacted the game?
Yeah, so there's a few. From a officiating standpoint. We're using the tracking data in the ball, and if you're watching a game on a Sunday, or this Sunday or Saturday for the divisional round, when a punt is going out of bounds, you might notice a official look down at their watch. That's an alert system that we have that's estimating where the ball crossed the out of bounds line to help make them more accurate in spotting balls that go out of bounds. That's one area where we help with officiating. In terms of game rules, we have a great football ops department and data analytics team in New York that will use NGS data to try and promote new rules and change the game for the better, increase pace of play, make the game safer in conjunction with their player health and safety team. If you look at the new dynamic kickoff, which was designed to both increase the amount of kick returns in the game while also making it a safer play. A lot of the iteration on that, where the original idea came from Amazon's very own Sam Schwartzstein with the XFL, a lot of how they kind of fine-tuned it and have adjusted the rules have been using the tracking data to better accomplish, what their achieved goals are with that play. And then from a team perspective, in weekly game planning and prep, they're able to get data, that was traditionally manually charted, and expedite their processes in those ways, as well as for player evaluation, dive a lot deeper than just the trained eye, which is still plays a very, very huge part in it, but just adding more nuanced data and deeper kind of looks towards evaluating players. And then finally, where we come into play is from a broadcast perspective. We are, helping get, the analysts in the booth real-time tendency updates, because you can't possibly track all of that in real time. So if you're hearing on this Sunday, maybe Tom Brady saying that the 49ers have gone a lot more 22 personnel today, that's usually, he's looking at the game itself, but we're working with his spotter to confirm or, maybe dispel things he might be seeing on the field, and maybe, new strategies that are popping up. We're trying to alert that booth so they can integrate it into their commentary. We can build a whole package around it. We can add visual graphic support to what they're saying. It's a very, comprehensive impact it's having on both how the game is covered and, how teams are operating.
Got it. Yeah, that makes a lot of sense. I think that it's really interesting how part of this is automating what used to be done manually, right?
Yes.
And then part of it is innovating and doing things that could not be done before.
Right.
Yeah. So let's take a second and talk about the high level architecture of how this solution works. So I'm going to go ahead and share my screen and just go over that. So here we have a very high level, not specific architecture diagram, but I do think it's really helpful. So the way that NextGen Stats works is you have data that's coming from the stadium. And the data that's coming from the stadium is coming from RFID chips that are implanted in the player and the ball, and those are chirping out data. So we'll talk more about that in a moment. But there's tracking data. So that's the real-time tracking data of exactly the position, speed, and all the information about all of the different items we're tracking, including the players. And then from there, that data gets streamed. So there's a stream is a bunch of small data points that are being emitted and ingested and processed in real time. So there has to be a full streaming solution built up on AWS to ingest this data, process the data, and then it also displays that data, powering those statistics that Keegan is talking about. So there's a whole pipeline here of moving the data from the stadium to AWS, processing, going through, calculating the statistics in real time, and storing them, and then displaying them. So we have real-time streaming that is powered by Kafka. From there, the data makes it to AWS, and the NGS solution is running. And what this does is it has tons of different processors for different stats. So based off of that real data, it will calculate the different statistics that you are measuring and targeting. Those statistics are powered by machine learning. We're going to talk more about each of these steps in depth over the next, let's see, how much time do we have? 45 minutes or so left. So we'll cover each of these steps more in depth. And so it goes through, it will run inference on that data to predict the target variable, meaning the stat. Those stats are then stored, and from there, they're used for various different things. They are used for on-screen graphics, they're used by the media team, and they also are shared via APIs for other types of consumers of this data that they use for their own purposes. So there's a full end-to-end process going on here. And I actually see, it's kind of funny, somebody has a comment here that says, ETL, extract, transform, load. And in some ways, right, that's true, right? We have our data source here. We have our data source that's giving the real data. We are ingesting that and transforming that into statistics. And then we're loading that data into analytics platforms powered by AWS services like QuickSight to actually view and use that data. So that's an interesting comment there, right? So we're talking about a data pipeline, and that involves collecting data, ingesting it, processing it, and then using it. So that being said, My bad. I removed myself from the stage on accident. So that being said, we did have the opportunity. Alex kind of hinted at it earlier. Alex and I had the opportunity to go to NFL headquarters in LA late last year and interview some of the engineers and main players who built and operate NextGen stats. And Keegan, you were one of those people that we were able to speak to. So we actually have a clip from when we were able to go out there, and this is an excerpt from a series that we're going to be releasing on YouTube. So this is a little teaser for you. If we can go ahead and roll that first clip.
Now, let's actually talk a little bit about the tech here. You've got all of this data, all of these stats that are being generated, at stadiums all over the globe. What do you do to get that data back into AWS?
So the tracking system is an RF-based tracking system. And so all of the players are wearing an RFID chip in their shoulder pads.
Have you gotten to try out these tags yourself?
Absolutely. Do you want me to go grab one?
Yeah, that'd be really cool. Yeah.
So these are our player tags. This is actually the ball tag that's installed inside the ball. And then these are the player tags. There's one under each chiplet. Those chips chirp out 10 times a second. We have a system installed around the ring of the stadium that's listening for those. It goes back to a server stack, process everything, send it to the cloud, up to AWS, and then that's where all the good stuff happens.
That data goes over standard internet connections, over 10 gigabyte pipes, and they arrive at our servers in the US East 1 region. And we built specific streaming servers to receive all of that data, and then that goes into our processing pipeline. Our processing pipeline consists of over 200 different Java and Node and Python processors that are consuming messages off of a message broker, which we're using Kafka for. And then the various processors have all sorts of different tasks. Some of it is to just store it into the database. Then it prepares it for consumption by our media partners, our teams, and our fans.
All right, so that was just a quick clip of diving a little bit deeper into the architecture and how this works. But Keegan, can you tell us, how is this working with the RFID chips, and how did you guys land on using RFID, and what types of data is being collected by those chips?
Yeah, so Zebra Technologies is the actual hardware company that runs the entire data collection operation in the stadium. It's their technology that we're using in the shoulder pads and the chips, and they're bouncing off those sensors in the stadium to give location data for 10 frames per second for every player on the field. So that includes XY on a 120 yard by 53.5 yard field of play, and from there, they also smooth the data to derive speed, direction, orientation, acceleration, etc. And all that tracking data on its own is interesting, but it's kind of useless without context. So the other key thing and key part of this process is there are video loggers within the stadium who have a little iPad, and this is what I mentioned earlier I did in 2015, and they're saying, hey, that the huddle just ended, and now the line is set, and the ball is snapped, and the pass is thrown, and that is a complete pass, and then the player is contacted, and then they're tackled. And then there's two other QA teams that are seeing those events, watching it with video, verifying, and then adjusting it to be as accurate as possible with side by side with the video. So now we have context, and we can start to split the data to tell you, when certain events happen. When the line is set, where's everyone aligned? That's their position on the play. When the quarterback throws the ball, how much time was between when the ball was snapped and the ball was thrown? All right, now the ball is thrown. Now we know what receiver is being targeted and what defender is targeting them or is covering them. So from that and all the processes that we've built over time, we are collecting over 500 stats in near real time. Those stats are going through our data processing pipelines and appearing in our APIs once fully validated within about a minute to 2 minutes after a play is concluded. We also have kind of experimented with automated events, so we get real-time approximation of stats that will come in pretty much instantaneously. So if you're ever watching a Prime Vision broadcast and you see something pop off the score bug in terms of completion probability or yards after the catch, right after a play happened. That's what's using that real-time processor as well. So yeah, over the last decade, we've built out all of those different data processing pipelines, from very simple business logic to machine learning models, to be able to process all of that and have it available in a live setting.
So follow-up question on that. You mentioned there's like a prime broadcast, because there's multiple different broadcasts going on, right? So like there's one specific broadcast that's great for NFL sports analytics nerds, right?
Yes.
Which one is that?
That is Prime Vision. So on Thursday nights during the season, and the amazing game we just had this last Saturday between the Packers and the Bears. Anytime there is a game on Prime, there's the main broadcast, which is the traditional broadcast with Kirk Herbstreit, Al Michaels in the booth, and you can stream it on Amazon Prime. But there's also, if you go down on your screen, go over to the side, there's an alternate broadcast called Prime Vision. And that's something that is powered by NextGen Stats. And we work very closely. I'm actually in the studio with Sam Schwartzstein, who's the talent for that broadcast, who will pop in and show you the AI features that they've built using our data to show you things and really draw your eyes to, things that are important on the football field. They highlight someone who is likely to blitz. They highlight players with a green orb who are open on a passing play. If a player is about to get pressure, they light them up as they're pass rushing in real time. They have built things such as, field goal target lines based on some of our models. They've built fourth down kind of, rather than just having the yellow line where the first down is, we have a blue line where you need to get to where we would recommend going for it on fourth down. It's a very data intensive broadcast. And one of the best parts is it's not your traditional angle. It's from behind the quarterback. So it looks like you're almost playing Madden.
Okay. So that's really cool. I think people, if you are interested in this, check out that broadcast. It could be really give you some extra insight and stats and a little bit more excitement. We do have a question that I want to see if you have an answer to here. So how do you handle replays? Like when a play is annulled, but it was already stored by the system? I know you mentioned there's a group of like QA analysts kind of watching and trying to correct anything as it comes along.
Yeah. So if there's a penalty on a play, it will be tracked as a no play from GSIS, and we will have certain pipelines that determine whether we are going to calculate certain stats, run certain models based on the play type. So if it's a rush or a pass or a sack, we'll run certain models. But if it is a no play because the penalty, maybe there was a holding penalty or defensive pass interference penalty, then we won't run our models on those plays because it doesn't count towards the official stat keeping of the NFL as determined by GSIS.
Okay, awesome. All right, thanks for answering that. And we also do have one more comment here. That is my perfect transition. And this person says, are you using vector databases? And I don't have a specific answer to vector databases, but the thing that's interesting is that there are multiple different types of databases. And we talked about this whenever we went and spoke to you all in LA. So let's go ahead and roll clip 2, which talks about storage. Once the data has been distributed to the processors, there's going to be some sort of storage mechanism that has to happen. So where are you storing things like the raw tracking data, for example?
We store the raw tracking data in a few different locations. Our project started with Mongo, and all of our raw tracking data got stored into Mongo, and then we used S3 as a backup for our raw tracking data. And then as time went on, we saw that the data just kept on growing. There's over 2 gigabytes of raw tracking data per game. That's a lot of data to be able to query against. We tried a few different technologies, but we eventually arrived at Cassandra, which allowed us to have a very consistent query response time, regardless of how much data exists in the database.
All right, so it seems like you've got a whole lot of data. You're storing it in a variety of database solutions. But let's talk a little bit about processing that data. Namely, we can't just leave it in the database and hope that it does something. We got to do something with it. Just a minute ago, you mentioned 2 terms that I was hoping you could just define for the folks. You said something a little bit about business logic and machine learning. And I just kind of wanted to hear maybe what those were and then why you'd use one versus another?
Yeah. So business logic is simply just like writing your own code, using simple, maybe arithmetic or whatever it might be, to classify certain things, a bunch of if-then statements, maybe more logic-based. So for instance, the air yards is the yards a pass is thrown past the line of scrimmage. So you take where the receiver was when the pass arrived, and you subtract their X location from the X location of the line of scrimmage, and that would be 5 air yards, 20 air yards, 30 air yards, etc. They're simple stats. What is the speed of this player? You convert the yards per second to miles per hour because it might be more digestible. We have positional alignment. Okay, so first we identify the center. Who's next to that player based on their location? Those are the guards. Then it's the tackles. All right, next player. Are they within 2.5 yards of the offensive tackle? Then we're going to call them a tight end. If they're the widest player, we're going to call them a wide receiver, et cetera, et cetera. So those are all simpler stats that we are able to kind of productionize pretty quickly. And then there are machine learning models. Where we train a model. A lot of times now we're using more transformer models to try and classify a more complex thing that would take, millions of lines of code to capture all the nuances of. So if you wanted to try and use business logic to classify coverages, that would be really, really, really hard. There are a lot of interacting parts. There's, up to 5 different receivers running different route patterns, and how the defense is reacting to those can make the same called coverage look somewhat different. So what we do there is we use the trained human eye because it takes a lot of domain expertise to kind of really understand the nuances between a cover 6 and a cover 4 scheme. And we use those labels to train a model based on the movements and the interactions of those players on the field through, as I said, CNNs, transformers, different types of machine learning models in order to build out those classifications. Then we, validate, make sure that the predictions make sense. And that's how we are classifying, complex football schemes in real time.
Gotcha. So it seems like you've got the, simplistic, this is just a binary, I've kind of got a number, versus the machine learning covers things that are, I would need 1,000 if then statements sort of idea.
Exactly.
Now, did you all start with primarily business logic and kind of move on to machine learning, or did NextGen stats kind of go straight into the machine learning deep end?
Oh yeah. I mean, we started with speed and distance, like the simplest things you could possibly do. Then we were like, okay, maybe we could tell you a little bit about where the ball was thrown or where this player lined up. Back in 2016, our toolbox was pretty limited. But over the years, it's really evolved. And that started in 2018 when we partnered with AWS to create a new machine learning statistic every offseason. So when we first dove in, we were kind of a little gung-ho, and we were like, oh, well, let's try and make brand new things that have never been discovered before, like completion probability or expected rush yards. And a lot of this is also built off of the Big Data Bowl, which is a open source competition that we really release our data to the public and really see what everyone can come up with there and borrow from that. But as we kind of iterated through and worked with our broadcasters, we figured out that meeting them where they are is going to increase buy-in a lot more, and also just make for more useful analysis. So that's, over the past couple of years, we've shifted from kind of these esoteric, harder to understand models that maybe some old football guys might scoff at, to more like speaking in their language. Who's getting pressure? Who's blitzing? What are the coverages? What players are running which routes? And we've seen, the fruits of that immensely in terms of the buy-in we now get from pretty much every broadcast crew.
Now, you mentioned completion probability, and I know that's a huge stat for NextGen stats. Talk a little bit more about that and why that's important.
Yeah, so completion probability is a way to approximate the difficulty of every throw. So, if we look back in 2018 and Drew Brees is completing over 70% of his passes, breaking the completion percentage record on a season, that's really impressive, but it also means that he might be throwing easier passes than someone at the time, maybe like Cam Newton or Jameis Winston, who's kind of just slinging the ball down the field. Not all passes are created equal, and a 5-yard check down into the flat is usually going to be a lot higher percentage throw than a go ball down the sidelines into double coverage. So basically what completion probability does, it's an XG boost model, and it takes into account the dynamic factors of a throw. How fast is the quarterback moving, and what is his directional momentum compared to where he's throwing the ball? How close is the pass rush to that quarterback? Are they affecting his throw? How far is the pass? Farther passes are going to be harder to complete. You have a lot more margin for error. How tight is that window that he's throwing into? Are there defenders that are kind of in the path of the throw? Are they close to the receiver where they can make a play on the ball? And you aggregate all of that. Are they close to the sideline where they need to put their 2 feet in? And you can contextualize how difficult a pass was. So aggregated onto the season long level, we can determine whether quarterbacks are making easier passes, harder passes, and how they're performing based on the difficulty of their throws. Now, what completion probability is not is catch probability, because we don't know the accuracy of the pass right now. And we don't know, the famous Odell Beckham catch from 2013. We wouldn't be able to properly account for the difficulty of that pass because we're just looking at 2-dimensional tracking data. We have no idea that he's completely outstretched one arm. And we hope to get there eventually as we start to look into computer vision. Hawkeyes just started collecting data in every stadium this season that has, rather than just 2-dimensional tracking data, 26 different joints for every player that they're tracking. And, the fidelity, it's going to be a long road to get to the same level of accuracy and fidelity, if it's even possible with computer vision data compared to what we have with the hardware right now, which is quite accurate. But, it's very exciting to see that we're not even really still scratching the surface of all the different things that we can capture on the football field.
I'm sure, though, that when y'all first started doing the RFID stuff, I'm sure some people thought that was crazy as well. Yeah. And it's like, it's a bumpy road to get there. But now here you are like 10 years later, and it's like, it's really accurate. It's impacting the game. People love the stats. It's, it's important work. So I agree. I'm really excited to see how computer vision and everything moves on. Because I was even thinking about that when you were saying that there are people on the sidelines with iPads, kind of like, okay, this is the beginning of a play. This is the end of a play. This is what's going on, to contextualize the data, because the data itself is like raw, coordinates, right? So exactly. There needs to be more data than just the coordinates to make sense of that. So that makes a lot of sense. And like I said, I'm going to be interested to see where things go in the future with all of this new technology popping up. And one other thing I wanted to mention as well is with NextGen stats, you're able to quantify what is a feeling in the past. Like whenever you're watching an exciting play and someone makes a really difficult pass and then they make a difficult catch, and it's like, you're so excited. It's like, oh my gosh, I can't believe that happened. Now I feel like it's like we can mathematically tell you that we can't believe that happened.
Yeah. Quantify and contextualize. That's our job as a research analyst too. When a big play happens, we're all scrambling through our dashboards, a lot of which are built on a QuickSight. How do we contextualize this in the fastest way and get that to the broadcast so they can share it, and really have that exclamation point on what we just saw with their eyes.
Awesome. So you also mentioned that with the development of these machine learning models, the NFL partnered with AWS. Can you speak a little bit about the partnership there and how AWS was involved with creating these machine learning models?
Yeah. So we work with I believe it's the ProServe team now. It seems like they change their name every year, as want to do. But we work with some brilliant data scientists at AWS, and usually starts around March, April, May. We'll scope out a project and we say, hey, this is one of the stats that maybe is missing or is weaker in our toolbox right now. We want to work with you all to, build a new model to capture this, and this. This past off season, we worked with engineers such as Chris Boomhauer and Kevin Song, and we built a suite of models called coverage responsibility. So we trained models on labels that we had from a charting service of what every player that was playing coverage, what was their responsibility? Were they responsible in zone coverage for the deep left half? Were they the hook curl player? Were they in man-to-man coverage? Were they the hole player? And then from there, we determined wide receiver or route runner and coverage player matchups. So, in this game, Christian Gonzalez covered Quentin Johnston on 13 times and he allowed 0 receptions. That's a great use case there. And then finally, and this goes back to the business logic versus machine learning distinction. So in the past, one of our probably weakest stats is we would attribute the target and coverage to just the nearest defender. So it doesn't matter what you did on the play. If you were the closest to the receiver when the pass arrived, we said, you know what, that's simple enough. We're just going to say that you were responsible for that target. And while it was pretty accurate, when we actually tested it this offseason, about 75% of the time that was right, which, we aim for over 90% pretty much all of our stats. So, we built and it's the same architecture across all 3 of these models, which is really cool and something that the AWS team was able to figure out. But we're also now able to better properly credit who was responsible for a targeted pass on that play. You put that all together and we just have a way better understanding of player performance in coverage right now than we did maybe a year ago in terms of the data that we collect at NextGen Stats. There's actually also, I will point out, we spoke at reInvent. So if you want to check out that 30-minute presentation we had, we dive a lot more into kind of the nitty-gritty of how that model was created.
If our chat mods can find the link to that talk, put it in the chat.
Yeah, I really can't recommend that enough. That was one of the things we definitely watched prepping to go down to talk to y'all in LA. Now, you mentioned a little bit about ProServe, and I know one of the big tools that they use is SageMaker. We're going to play a clip here in just a second of one of our conversations with some of the really smart data folks in your org, where we got to talk about the different kind of models and how you're using SageMaker to help develop these next-gen stats. So if you could cue that clip. So we talked a little bit about, how you're doing this. Could you tell me what tools you're using to make this happen?
Definitely. I think SageMaker is very incorporated in all of our processes. In the initial stage of POC, the proof of concept, it's super easy to just open up the SageMaker notebook, have the environment set up, have the right compute resources to be able to just try things and run quick experiments. And because you're kind of in that SageMaker ecosystem, it's really easy to move on to the next step, which is doing that processing job.
So how do you structure a SageMaker training job for one of these models?
So you launch a training job and say, here's my local script, run this in a GPU environment so that I could train it on a deep neural network. Everything kind of happens behind the scene. I'm not aware of it, but it kind of just works. And at the end of the day, you have the logs, you have the output that gets saved to another S3 bucket, and it's kind of all there nicely so that you could easily retrain, track experiments just by going to that training job instance.
All right, so in that clip, she was kind of discussing some of the different ways that SageMaker was used. And one of the things that I love that she said is like, I don't really know how it works, but it just kind of works. So I want to take a couple of seconds to talk about SageMaker and just the idea of using machine learning to generate these types of stats. So I'm going to go ahead and share my screen. And first, we're going to quickly discuss the machine learning lifecycle. So with the machine learning lifecycle, you first start with a business goal. And in the case of NFL NextGen Stats, Keegan, just like you were saying, it's like in the off season, let's identify some statistics that we would like to have for the next season. So you have a business goal, you have something specific in mind that you're looking to generate or to track or to predict. So for machine learning, a lot of the types of models that you're going to be looking for are predictive, right? So you're looking to take a bunch of inputs and predict a specific output variable. So from there, we have to frame the model as a machine learning problem. So Keegan, you also mentioned that, there are different types of algorithms. And I think you mentioned completion probability is using the XGBoost architecture, right?
Mm-hmm.
Yeah, so that's just one of the many different types of machine learning model architectures that you can choose. So depending on the type of problem that you're looking for, like, is this time series data? Is it text-based data? Is it image data? So depending on the type of data that you have and your desired output, you would choose a specific machine learning model architecture for each of those. And so after you choose how you're going to create this machine learning model and what you're going to use for that, you then need to process the data. So you likely have a sea of data that you want to train this model on. And having the data be ready to actually develop the model, you need to do things like clean the data. So maybe there are outlier values that could skew the data. Maybe there's incomplete data, missing values. If you're bringing in data from multiple different places, you might have to map columns to have them have the same name, or even like calculated columns, which I think are calculated features, which I think is something that the NFL, when we were there speaking, that is something we had talked about, was how sometimes with features, a feature is an input to a machine learning model. So sometimes with features, you might have multiple different raw data points that you are calculating to create a value, and then that value is the input. So there's lots of different things that go into the data processing aspect. And then from there, you can develop your model. Once your model is done being trained, you can then deploy it. And from there, once you deploy it, you will run inference on it. So inference is when you have new data that you're passing to a trained model that will then run and produce the output. So I think that one of the things that I'm seeing right now in conversations is like, there's traditional machine learning, and then there's the newest, latest, greatest thing everyone's talking about, which is generative AI. And these are different types of things. So we want to make the distinction here that the types of models that we're talking about for NextGen stats are really traditional machine learning models. This isn't using generative AI technology in the same way. So what you can do is you can monitor the outputs. So that means like, okay, we had new input come in on a play. We ran inference on all of our models. It made a prediction, it had the output, it gave a specific number for that output. And then you need to monitor like, okay, is this actually working the way that we think it's working? And we actually had a question here. How do you monitor model level metrics like prediction drift or feature skew in near real time without impacting inference latency? And I wanted to call out specifically how the NFL and many people using machine learning for all sorts of different use cases are using SageMaker. And SageMaker has features that would help you do exactly this. I found this in the documentation here. So we have feature attribution drift for models in production. So Amazon SageMaker Clarify is a feature that can help you monitor your predictions and for feature attribution drift. So that means that the model is going to be actively monitored in real time, and it will send data to Amazon CloudWatch, which you can then create alarms for to send out notifications if you do see significant drift. So if we can, I'm going to go ahead and just throw this over to our chat mods who can paste that link to answer that question there. But let's go back to SageMaker really quick. So with SageMaker, once you determine how you are going to actually build your model, there's all sorts of different features that you can use to cover each step here. So fetching the data, cleaning the data, preparing your data, training your model, evaluating your model, deploying it, and monitoring it. There's different features within SageMaker for each of these steps and more. So if you're someone who's really interested in diving deep into machine learning and SageMaker, then I would recommend checking out a couple of these courses, which I'm going to have our chat mod throw into the chat. these are on AWS Skill Builder. We have fundamentals of machine learning and artificial intelligence and introduction to Amazon SageMaker. So that's a little bit about how the machine learning models are built and the technology that's used to create and deploy those. But I think we want to pivot and talk about a little bit about the QuickSight dashboards and how this data is consumed. So Alex, why don't we go ahead and talk about that?
Yeah. So, Keegan, you've got all this data, you've processed it. You're like, I've got my stats. I'm ready to go. Could you talk us through a little bit about what kind of happens next in that process?
Yeah. So basically, it's really split between pregame, in-game, and post-game. And our team of researchers uses all of the dashboards that we've built in order to split filter the data to kind of translate what they're seeing while they're watching the game into digestible, quick stats that can help, aid the broadcast, aid the conversation about the game, etc. So if I could actually share my screen, I can show you one of the research packets that we put together and kind of where, we find that general stuff. So here's one of our research packets. This is for the divisional round Seahawks versus 49ers game this Saturday. It is a kind of behemoth of a packet. We dive very deeply for Tom Brady and his crew. You'll be shocked to hear, but he takes his preparation very seriously when it comes to broadcasting, just like he did in his playing career. So all of these notes in here, about 15 pages worth, are coming from our database and our analysts who are splitting the data every which way. If you go here, you can see kind of all of our dashboards in production. So this is all these dashboards in the stats section are built on AWS QuickSight. And again, we can filter the data however we want. If we want to look at Brock Purdy in a by game perspective, include the postseason, and let's look at him maybe using play action because that's something that's central to Kyle Shanahan's system. Here is his performance in all of those games off of play action. You'll see last time he played the Seahawks, wasn't very effective, just 4.2 yards per attempt. Now to take a little bit of a look behind the curtain, here's what these analyses that we build in QuickSight look like, as we're designing them. So we can add new fields here. We can format it any which way we want. And again, these are dashboards that are built by researchers for researchers. They're very, can be overwhelming at times with all the different filters and stats that we build, but this is the best way that we are able to perform our duties during the week and on game days of filtering down this information for the most important stuff. So if we go and we look at this matchup, one of my favorite storylines heading into the game, 49ers unfortunately lose star tight end George Kittle. They're usually a 21 personnel team. So that means they base out of 21 personnel. They have 2 running backs on the field and 1 tight end and 2 wide receivers. The Seahawks, we can see here pretty easily. They are a nickel defense. So they base with 5 defensive backs on the field. Normally, if you're in heavier personnel on the offense and you're a nickel defense for the defense, that's a size advantage for the offense. You have an extra tight end or an extra big body who is blocking a defensive back. Now, one of the things about the Seahawks this year is they have a 6'3", 230 pounds safety that they use as their 5th defensive back. So it kind of neutralizes that size advantage they have. And you can see here, going against 21 personnel, they're almost always matching with nickel. If you look at the rest of the NFL, they're 96%. Rest of the NFL is 39%. So very out of the ordinary. So they're going to line up and play you regardless of who you send out. And then for the 49ers, they actually might run a little bit more 22 personnel, which is getting even more big bodies on the field because now they don't have George Kittle, who's kind of that do-it-all secret weapon. They need to bring extra big bodies on the field. Seahawks probably still going to match that with nickel personnel. So it'll be a fun, stylistic battle of, just overall tendencies of the 49ers always try and get teams to get extra linebackers on the field. They can play action off of that, hit deep shots, and, create explosive plays. And then the Seahawks are, built so well from a personnel perspective. They say, we don't care what you're on offense. We're just going to line up and play you and knock you in the mouth. And we dare you to try and do that. So that's just like a quick way of how we're utilizing these dashboards to pull all of those stats, craft them into a storyline, put them in the research packet, and send that over to our broadcast partners.
So that's a whole lot of data to say that the Seahawks are going to win this weekend, right?
The Seahawks, I would say, they have a lot of answers for what the 49ers strengths are. So I'd say they are the favorites.
Well, I'm glad to hear that. Now, for the folks following along with us, if you're looking at this and thinking, that looks great, I'd like to use QuickSight myself. In the chat, we're actually going to have the chat mods drop a link to another one of our courses. This one focuses specifically on QuickSight. The bad news here is we don't have NFL data for you to play around with, but I still promise it's worth going through. Now, Keegan, you mentioned a little bit about you've got your research packet that you develop before the start of the game that you hand off to the broadcasters, but could you talk us through a little bit about what happens during the game? Because I'm sure some of the stats and data that you're pulling in are going to influence what, Tom Brady and all the other folks with the headsets are going to be talking about.
Yeah, so we have our game pages here, and I'll go back to last week's 40. Maybe, even more fun, we'll go to the Week 18 game between the Seahawks and the 49ers. They played just 2 weeks ago. So these are powered by our APIs, which, again, is processed through the whole data pipeline we've talked about. For any given play, we can look at, the overall dots. So let's look at something fun. Let's look at the only touchdown of the game. Instantly, you're seeing that two-dimensional tracking data in the dots right here.
Can you zoom in just a little bit to make the page a little bit bigger? Yeah. I don't know if that's just me.
I'm trying to zoom in. Where's the zoom?
It's all right if you can't. There we go. Okay, perfect. That's great. Thank you.
So you can see this is what the tracking data looks like on the field. And then side by side, this is what the film looks like. And the great thing about our web pages is they're synced. If my stream works well here, but you can see here's what we're seeing on the film. Here's the dots. Here's the representation of it in two-dimensional data. And in this, on these play pages, we have all the different metadata that I was talking about earlier. How fast is everyone moving for every 10th of a second? How much distance have they traveled? What's their acceleration? As well as a bunch of stats here, expected rushing yards. When the ball was handed off, and maybe see if you can agree here, what did we expect Zach Charbonnet to gain? Well, he's already cutting back, and there's only one defender to beat there. So if he only has to beat this guy, 7 yards, that seems like a pretty good expectation there. We have the formation, the receiver alignment, all this different stuff that we're collecting at the play level. Now, these are the plays we can go back if we, want to go during a commercial break and watch the last drive, go back, watch the film, and kind of see if we're picking up on anything. And then we know, all right, we can go here and just start to see all these different splits that we've built out over the years and see just, how these players are performing in real time. So we can tell you that, under pressure, Brock Purdy wasn't doing too well. 3 of 7, he only gained 25 yards. We could tell you that from a team perspective, the Seahawks only missed 3 missed tackles in that game, whereas the 49ers missed 21. It's a pretty big difference that's going to really affect how the game is being played. We can tell you how often is a team playing man coverage or zone coverage? How often are they playing aligning in press coverage? What is the success rate for each team, etc. So all these stats available in near real time. And again, we tell all of our analysts, watch the game and then know where to find it, communicate that out through Slack, through headset, whatever our communication channel is with the specific crew. So it can get fed to both the graphics team to build graphics around it and the booth so they can, alert people to what might be going on that they're not seeing as they're, talking for 3 hours and have a lot of other things that are going on. So we're providing that extra support there.
Awesome. So I think what's really cool thinking about this is, again, it's like, this is the end product. But under the hood is all of that really cool, innovative tech of the full end-to-end pipeline, ingesting that RFID data, calculating these statistics, and then serving it to this webpage or other broadcasters, all that sort of stuff. So I feel like this demo gave us a great cap on the full end-to-end process and what this is actually powering at the end. So thanks so much for doing that. I'm also curious to know, what else is the NFL doing with AI and machine learning? I know that there's some other things that you guys have done around draft IQ and combine IQ. And we only have 5 minutes here left in the stream, but I'd love for you to just take a minute or two to highlight that.
Yeah, and I actually have those up real quick so I could do a quick run through. So during the combine, every player is wearing chips in their not pads, but their workout gear. So we can tell you, how fast they're running during the 40. So not just, what their speed is, what their time is, but how fast they are. During all these drills, during the gauntlet, how much can they maintain their speed as balls are being thrown at them left and right. So this was actually surfaced to fans through NFL.com. So they could see in real time all of this extra data that we were starting to collect at the combine, as well as all the traditional metrics there. And then we also have our draft scores, which is a model based on predicting how well a player is going to perform in the NFL based on their athletic profile and college production profile that you can see here. And, we can just evaluate prospects in that manner. And then during the draft, we had a live draft tracker that, we have overall draft class composite rankings based on our NGS draft score models. We can tell you from a team profile, looking back, how did your team draft, give you some analysis, give you kind of what we thought the big boards were, what the odds were of each position, just an overall high level overview of what this team was doing. We had, big boards you could play around with and do mock drafts with. And this is what it ended up being. As well as a live big board for who are the best players left on the that are available, live during the draft. And we're hoping to evolve this even more this year to tackle free agency and really everything that happens in between the last game that's played and the preseason to see how your team is improving or changing over the offseason.
That's so cool. I love seeing, what's happening with AI, machine learning, with the NFL. And, we did a lot deeper of a dive into NextGen stats whenever Alex and I came out to the NFL to interview you guys. So I just want to plug that series. It's going to be coming out on YouTube, on the AWS YouTube channel. So if you want to go ahead and you can find me on LinkedIn, give me a follow, and I'll be posting that. And, keep an eye out for that series. We're going to go a lot deeper into the technology. And if this is something that interests you, we're going to continue to talk about it and highlight all of the great work that you guys are doing over there with the NFL to make the game even more exciting than it already is.
Now, Keegan, I just got to interject here real fast because we are almost out of time, but I have to know, who do you think is going to go all the way and win the Super Bowl this year?
Before the playoffs, my pick was the Rams over the Texans. And while I feel a little bit better about the Texans, a little bit worse about the Rams after the wild card round, I'm going to stick to my guns and stay with that prediction.
Well, selfishly, I was hoping you were going to say the Seahawks, being here from Seattle. But, we can all have differing opinions.
Yeah, and I think it'll be close. The Seahawks, if I had to pick a non-Rams team from the NFC, it's probably the Seahawks. So I think if they do meet in the NFC Championship, their first two games are excellent, especially the later game in the season. I believe it was week 16. If we can get a repeat of that, that would be just awesome for the league and, just overall football fans.
Yeah, well, it'll be a fun game no matter who's in it. So I just want to say thanks. We are out of time now. Thanks to everyone who joined us and went through this series or this content with us. Like I said, please watch out for that new series. We had a lot of fun filming it. You'll see myself, Morgan, Keegan, you're in it as well. It was a great time. So thank you so much, Keegan, for joining us.
Thank you.
Sure you've got some more work to do here prepping for that Super Bowl. So I don't want to take up any more of your time, but thank you so much.
Yeah, thank you so much.
Everyone.
Awesome demo. That's really exciting. So thank you so much for coming.
Yeah.
All right. See you guys later. Thanks for joining.
Yeah.